Welcome back to Wondermass, and today we are solving the base rate fallacy with hardly any mathematics. Now on the screen is the base rate fallacy question from Wikipedia. And Wikipedia says that when people read through this, they estimate the probability to be as high as 95%, but in reality it's less than 5%. And we are going to demonstrate that using a spreadsheet. We're going to simulate this situation in a spreadsheet and come up with an estimate for the probability that the driver is drunk. Now, in reality, you probably wouldn't do this in a spreadsheet. You would simulate it in a programming language, but I think working through it in a spreadsheet illustrates the problem in a much more accessible way. And most of you will have a spreadsheet on your computer so you can do this yourselves. So the story that we are simulating is that we've got a driver, we've got some police, they stop the guy and they breathalyze him. The guy that they stop, there's a 1 in 1,000 chance that that person is drunk. If they are drunk, the breathalyzer will say that they are. If they're not drunk, there's a 5% chance that the breathalyzer will incorrectly say that they're drunk. Otherwise, it will say that they're fine. That's the story, and here's how we're going to simulate it. This is all we need. So we want two columns really. A column to say whether or not the person we stop is drunk, and then what the breathalyzer says. This over here is how I'm going to simulate whether or not the person is drunk. So what I'm going to do is I'm going to use the rand between function and generate a random number between 1 and 1,000. So 1 comma 1,000. And then I'm going to, in the drunk column, say if that number that we've just generated equals, and then I'm going to just choose any, sorry I missed my if that number equals, and then I just choose any random number between 1 and 1,000. So I'm going to use 999, but it doesn't matter what you use, you could use anything. If the random number that we've generated equals 999, which will happen 1 in 1,000 times, then the person is drunk. And I'm going to represent the person being drunk using a 1. Why? Because later on I want to count the drunks, and to count ones I just have to sum them up. So it's super easy. Otherwise it'll be a 0. And there it is. So that has simulated the driver that we've just stopped. Now we have to simulate the breathalyzer. How are we going to do that? Well, equals if, open brackets, if the person is drunk, so that cell there, if that equals 1, then the breathalyzer is going to correctly say that they are drunk. So it's going to be 1. Otherwise, we need a nested if. So if, open brackets, and if we toss a coin that comes up heads 5% of the time, comes up drunk 5% of the time, then we're going to say that the person is drunk. Otherwise, we're going to say that they're not. So how do we simulate that coin that comes up 5% of the time? I'm going to use the rand function, R-A-N-D, open and close brackets. That will generate a random number between 0 and 1. And if that is less than 0.05, which will happen 5% of the time, then the breathalyzer, says drunk. Otherwise, it says 0. Close brackets, press return, and that's our simulation done. And then to run the simulation 1,000 times, which actually won't be enough in this case because not enough people are drunk, but if we wanted to run it 1,000 times, all we would have to do is click and drag the formulas down. Now I'm not going to do 1,000 on screen, I'll do 316. It's unlikely that we've found a single drunk person, by the way. No, I don't see a single one. But there are some mistakes. Okay, so that person has been pulled over, and dear love them, they're in trouble. They've just been caught as drunk when they're not. Anyway, we haven't caught a single drunk driver all night. I suppose that's good for society. So hopefully you already see why people are finding these sort of problems so challenging. The reason is because the condition is hardly ever met. So the condition is that the breathalyzer says the person is drunk, and it hardly ever says the person is drunk. In actual fact, I don't know, it looks like we've got maybe 5 or 6 here, just in this simple sample. And that's a challenge for people to process in their brains. So what I'm going to do using the magic of television is run this simulation 5,000 times and summarize the data, and then we can estimate the probability. So I'm just going to do it 5,000 times. And there it is, 5,000. So what I'm going to do now is I'm going to take our 2 columns and I'm going to copy, Control C, and I'm going to paste them into a new spreadsheet. I will do paste special so that I only get the numbers. Yes, please. Right, then I am going to use autofilter, and I want to select the ones, the breathalyzers that come up drunk, because that's my condition, and there they are. So again, I'm going to copy paste those into another spreadsheet. Because I don't want any interference from the other numbers. So let's put that in a spreadsheet. Oh, and there we go, we've got somebody who's drunk. We've actually caught somebody. Okay, so what is the probability? Okay, the probability is the number of drunks that we have here. So how do we find the number of drunks that we have here? Equals sum, open brackets, and then click and drag up. Actually, it would have been easier to just type the values in, but anyway. We've got 5 drunks divided by 292. So we've got 292 that meet the condition. We've got 5 drunks. So our probability estimate is 5 divided by 292. There it is there, 0.017. And if we have a quick look at the Wikipedia page for the base rate fallacy, they estimate the probability of being drunk, given that the breathalyzer says the person is drunk, as 0.019. We got 0.017, so actually that's quite a good estimate for only simulating 5,000 stops. I hope you enjoyed this video, and I will see you on the next one.